Hi everyone and welcome back to Life with Technologies YouTube channel. I hope you're doing well and thank you so much for watching this episode. So this is another episode of our Huawei Lab simulation series. Remember, in this series we demonstrate to you how to configure, troubleshoot and implement different networking protocols or different networking technologies on Huawei routing devices. So if you are learning how to operate and manage Huawei routing devices, kindly check out this series. And if you have any challenges, maybe setting up the labs or even setting up the lab simulation environment, either ENSP or EVNG, please do reach out and we will be glad to help you set up the environment so that you can follow the lab simulation that we are sharing on this channel. So in this episode, we are focusing on how to implement OSPF Shamling on Huawei routing devices. So OSPF Shamling, this is a special type of a virtual link that is used in OSPF, especially when you have MPLS layer 3 VPN environments. So you can see in this setup that you have the MPLS backbone network. This is the service provider network, and you have two customer edge devices. So you have C1 connecting to PE01 and you have CE02 connecting to PE02. These are CEs in different locations. But apart from connecting to the MPLS backbone, they also have a backdoor connection. So we have a direct connection from C1 to C2, and this could be a low capacity link. So when you have such kind of a setup and between the CEs, you are using OSPF as the PECE routing protocol. So this link we have OSPF configured. We also have OSPF configured on the other end. And remember, between the C1 and C2, you also have OSPF implemented. So with such kind of a setup, we'll have what we call suboptimal routing. Remember, when routes are advertised from P1 to P2 and then advertised to C1, we will have the inter-area routes. So P1 and P2 will be advertising the routes to C1 and C2, but these routes will be inter-area routes. So when C1 is sending traffic to C2, he will use the direct link. So we'll be using this suboptimal link to forward traffic from C1 to C2. But the goal of setting up the PECE or connecting to the service provider network is that our primary link should be through the service provider network. So C1 should be forwarding traffic to P1 and then P1 should route traffic to PE2, PE2 should route traffic to C2. And the only scenario when the back-to-back connection or the backdoor link should be used is when we have an issue. Maybe we've lost the connection in our MPLS backbone or the service provider network. That's the only case where the traffic should be forwarded through the backdoor link between C1 and C2. So that is the issue that we are trying to solve to ensure that the traffic from C1 should prioritize to use the link between C1, P1, and then P1 should forward the traffic to PE2, and PE2 should forward the traffic to C2. That should be the primary link. And then we can use the backdoor link as the secondary link. So we will be configuring this in this lab, and in our MPLS backbone, we'll be configuring OSPF as the IGP. We also need to do some MP-BGP configuration between P1 and P2. We need to set up MPLS, and then we need to set up the PECE protocol, which is between the PEs and CE. And remember, we are using OSPF between the PE and the CE. So we'll implement VPNs on the PEs, and then we need to configure these interfaces between PE and CEs. We need to bind them into the VRF, the VPN that we will have configured on the PEs, and then we'll go ahead and implement OSPF on the C1 and C2. So the OSPF configured on C1 and C2, first we have the adjacency towards the PEs, and then we have the adjacency between the CE and C1 and C2 through the backdoor connection. So this is what we'll be implementing, and remember, we are trying to solve the suboptimal routing. We are trying to avoid traffic from using the backdoor connection between C1 and C2 and prioritize traffic to use the connection through the MPLS backbone or the L3 VPN that we've configured for these customers. So for the implementation step, it should be straightforward. So we have the configurations. Starting with the basic configurations on the PEs, so we need to configure OSPF. Remember, we need to have reachability in our MPLS backbone. So from CP1 to P01 to P02, we'll implement OSPF. We need to configure MPLS. And remember, when you are configuring MPLS, you need to first configure the LSR ID. So this one should be the first command before you activate MPLS. And then we are using LDP as the signaling protocol. So you need to configure MPLS LDP, and that one should also be activated on the interfaces. So on the interface, we configure IP address, we enable MPLS, we enable MPLS LDP, and then we configure the loopback 0 IP. This one will be the one that we use for BGP peering sessions, the MPBGP. And then we have OSPF for the reachability within our MPLS backbone. So we do the same on P01 and P02, and we'll verify that our OSPF is up. We are able to ping the loopbacks between the nodes in the MPLS backbone. So starting with P01, I will copy these configurations and we'll do it step by step. If you see any command that you don't understand, you can reach out and we'll explain it to you. So I'll start with P01. And this one we are doing the implementation on EVNG, so we need to commit. And then we'll do the configuration for P01. So for P01, we also do the same, configure interface parameters, activate MPLS, both globally and on the interfaces, and configure OSPF peering sessions. So we'll do P01. So these are the commands. Again, we need to commit. So I'll do a commit command. Finally, on P02, we also need to do the same. We configure sysname, we configure MPLS LSR ID, we configure MPLS and MPLS LDP, and then we activate the interfaces. We configure IP address on the interface and configure OSPF on the node to achieve connectivity. So this is P01 and then P02. So I'll do the configuration on P02 and then we can verify the configurations first before we move to the next step. So I can display IP interface brief to confirm that we have the correct parameters configured on these interfaces. I can ping I need to ping the point-to-point connection. So from P1, we can ping .0 that is configured on P1. And then we can ping .3 that is configured on P2. So we have back-to-back connectivity. We can check the OSPF. So display OSPF peer brief. You see that we have two adjacencies, one to P1 and another one to P2. Can display IP routing table, and we should be able to have the routing information learned via OSPF. So from P1, we should be able to ping 2.2.2.2, which is the loopback of P2. And we should also be able to ping 3.3.3, which is the loopback of our provider router. So once we've confirmed that we have reachability, we can go ahead and now proceed with the other configurations. The next step configures BGP. Remember, this is a layer 3 VPN, so we will need multi-protocol BGP peering session between P1 and P3 so that these routers should be able to exchange VPN routes from the CEs. So starting with P1, I'll configure the BGP peering session. Again, we need to commit. Again, we do P2. So we are using as number 100. We configure the router IDs, we configure the peer, and specify the connect interface. Remember, this should be VPN v4 peering so that they are able to exchange the VPN routes. So on P2, I'll apply the configurations. I do commit. Then we can display BGP VPN v4 all peer. So it's still not up. We give it some time for it to be established. You can see that we have a session that is up. On P1, we do the same, display BGP VPN v4 all peer. So you see that our adjacency is up between P1 and P2. So we are good to move to the next step. In step 3, we need to configure VRF on PEs and enable OSPF on the connection between PEs and CEs. We also need to perform route import between BGP and OSPF. So remember, the PE-CE protocol is OSPF, and you need to ensure that the BGP routes are imported to OSPF. OSPF routes should be imported to BGP to ensure that we have bidirectional communication between the CEs. So we start by configuring the VRF. So we have VRF1 configured. You need to specify the route distinguisher. You need to specify the import and export VRF targets. On the interface facing the customer, we need to bind the VRF, so VRF1, and assign the IP address. We again configure OSPF. Remember, this is PE-CE OSPF, so we need to specify the VRF because we've bind this interface to a VRF, so we need to do the same, and we import BGP. So when we are doing the route import for BGP, you can use the best practice, or you can follow the best practices and use some policies to control what is imported between OSPF and BGP. Then area 0, we advertise this network. This is the network between towards the CE, from PE to CE. Again, in OSPF, we are importing direct routes and OSPF. So you do the same on P2. So we configure the VPN instance and bind the interfaces and activate OSPF towards the CE. So I'll start with P1 and do a commit. I move to P2, do similar configurations. So on P2, I do a commit. On P1, I can display IP VPN instance. You'll find that we have VRF1 configured. You can check the interface. See that we have this interface in VRF1. P2, you can do the same, display IP VPN instance interface. See that we bind this interface Ethernet 100 to that VPN or VRF1, the virtual routing and forwarding instance. So once we've completed these configurations, we can now go ahead and configure the CEs. So for the CEs, we need to configure the sysname. We need to configure the interface towards the PE. We also need to configure the interface towards the remote CE. This is the backdoor connection. Again, we are simulating a network. This is loopback 0, 50.50.50.50. That should be reachable from the other side. We create OSPF. In this OSPF, remember, we have to advertise the loopback interface so that it's advertised towards the PE. And again, we activate OSPF on the backdoor connection and also the CE-PE connection. So we do the same on CE2, and then we do the verification to ensure that the OSPF is up and we have the routes. So on C1, I'll do the configurations. And again, we need to do the configuration on C2. Actually, this one should be 192. So I'll just reconfigure the OSPF on P1. So we need OSPF 10, area 0, And then I will use the network command, this network command, to activate OSPF on the back-to-back connection between the CEs, and I'll do the commit on this CE02. I'll do the same. So once you've completed the configuration, we can now check the routing. So remember, we have OSPF. If I display OSPF peer brief, you can see that we have adjacency towards 172.100.100.2. This is towards the PE. If I display OSPF interface to verify that we have the interfaces activated with OSPF, you can see that this is 192.168.1.1. Let's check on C1. If I display OSPF interface, you have the OSPF activated on that interface. We are missing one interface, so you can see that this network command, so OSPF 10 area 0, we need to have this network command. So whenever you are configuring OSPF, you always have to give the correct networks that you want to be advertised. So now if I display OSPF peer brief, you see that we have two adjacencies, one towards CE and another one towards the PE. So if I display IP routing table, you will see that this interface, this network towards the remote CE is choosing to use the backdoor connection. The next hop has been set to 192.168.1.1. And this is the issue that we are trying to fix. We want this traffic to use our connection through the service provider, the MPLS connection that we've been given through the L3 VPN connection. And it should only use this backdoor connection when we have an issue with the service provider MPLS network. But primarily, it should go through the other side and through P1, P2, and then to C2. So what we need to do is we need to create a sham link. So a sham link, it's a kind of a virtual link, as I've mentioned. We are just creating a new OSPF adjacency. Via the L3 VPN, we create a new OSPF adjacency between P1 and P2 so that these routes from the PCEs will be intra-area routes. And then they will be preferred instead of using the backdoor connections. And again, we'll see that when you do that, you will still need to configure some cost parameters. So you will need to configure metric values on this link and this link and ensure that this link has a lower OSPF cost. So the first thing that we need to do is we will create loopbacks. So we create loopback 10 on P1 and also P2. We assign the IP address 11.11.11.11 on P1 and 22.22.22/32 on P2. You can see that these interfaces, we are also binding the VRF1 onto these interfaces. And in the OSPF that we've created, so we create OSPF 100 VPN instance VRF1, and we are configuring a sham link. So we create a sham link, and this is how you create a sham link. You use the command under area 0, you use the command sham link, and you specify the source and the destination. So the source on this interface, on this P1, will be 11.11.11, and the destination should be 22.22.22.22. The other side, we reverse the source and the destination, and we are assigning a cost value of 10. But before we do that, I'll show you the routing table. So if I do display IP routing table, VPN instance VRF1 on this router, this is the command display IP routing table, VPN instance VRF1, you will see that all these routes towards the CE are using the CE to CE OSPF. Like traffic from P1 to C1 is also using the CE to CE connection, the backdoor connection that we have. So you will see that we have some suboptimal routing between these nodes. And once we have the Sham link and it's well configured, we have the correct metrics, then this should not be the case. Traffic from P1 should go to PE2 and then to CE2. Traffic from CE2 should go to PE2, P1, and then C1. So with these configurations, we should be able to implement Sham link. So I'll do configuration on P1. And again, this is one of the questions that you expect, especially when you are going for an interview. These are some of the principles that you need to understand. If you are to be asked in which scenario do we use a Sham link, you should be able to explain it and give an example of such kind of a setup that we are having right now. So on P2, we'll do the same. So commit. Once we've done that, if I display OSPF Sham link, you see that we now have OSPF Sham link. I don't know whether we can see more details. Area 0. So you have more details here. You see the state is full, which means we have established an adjacency from P1 directly to P2. On P2, I can also show OSPF. I need to use display. OSPF Sham link. You can do area 0 and then you will see more details. So you have Sham link, it's coming from this IP. This is the source IP to the destination IP and the state is full. Type is Sham link. So now when I check the routing table, remember when I display the IP routing table on this router, this router was pointing the routes towards the CE was pointing to C1 on P1. On P2, it's still the same. Display IP routing table, VPN instance, VRF1. You will see that these routes are still pointing to the CE. This is because of the cost values. So we need to configure a higher cost on the backdoor connection, and then we should be able to use our Sham link to forward traffic, and the traffic should be able to fail over whenever the Sham link is down. So what I will do is on the CE connection, so interface Ethernet 1/0/1, display this. I will set OSPF cost of 100 and commit. I'll do the same on CE2 interface Ethernet 1/0/1 OSPF cost 100 and commit. So once I've done this, if I go back to P1 and display IP routing table, VPN instance, we are in the VRF, so it's VPN instance VRF1. You see that now towards CE2, we are now using the Sham link and the traffic is pointing to now PE2 instead of pointing to CE1. Again, when you check on C1, if I display IP routing table, you see that for this remote connection 60.60.60 on CE2, it's now pointing to the PE-CE connection. Before it was pointing directly to the other CE-CE2 back-to-back connection, the suboptimal link that we are trying to avoid. So you can see that with Sham link, we've managed to ensure that our traffic is using the Sham link or the L3 VPN connection that we have through the service provider network, and it can only fall back to C1, C2 connection when there is an issue in the backbone. So if I go ahead and shut down 100 on P1, I do interface Ethernet 1/0/0, I shut it down and commit. So we expect the Sham link to go down. If I do display OSPF Sham link, so it will go down after the timeout. On C1, if I display IP routing table, you can see that it has picked the suboptimal link that we have. This link will be low capacity, it could be having high latencies, or it could be unstable. So we are trying to ensure that the traffic is using the optimal path from C1 and C2, from C1 to C2, and that path should be through the L3 VPN connection that we have through the service provider network. So these are the configurations, very straightforward, very easy. You need to remember that you need to configure the cost on the back-to-back connection between the CEs should have a higher cost than the Sham link, and this is how you implement Sham link on the PE routers. Then you can verify using the command display OSPF Sham link. You can see that it has gone down on P1. If I undo shutdown, so you saw that on C1, it was now choosing to go through the back-to-back connection between C1 and C2. Once OSPF is restored, display OSPF here, brief. So the OSPF is back. When I check on this P1, was it on P2 that Sham link was down? P1 display OSPF Sham link. So you see that the Sham link is up, and now from C1 we should be back to using our L3 VPN connection, and you can see it from here. The traffic is pointing on the PE connection from this CE. So this is how simple it is to implement Sham link on Huawei routing devices. And remember, this is a question that you may find when you are doing an interview on network or networking. So you need to understand how it works, the principle that it works on, and how to implement Sham link on different vendors. It can be Huawei, it can be Nokia, it can be Juniper, it can be Cisco. You need to understand how to do the CLI configuration for this Sham link application. So thank you so much for watching this video. I hope you've enjoyed it. I hope you've learned something. And if you meet any challenges when you are doing this practice, feel free to reach out. We'll be glad to help you to complete this lab. And again, if you are struggling to set up the lab for your lab simulations, feel free to reach out and we will be glad to help you set up the environment so that we can go step by step through our videos and help you to master network engineering, especially in the hands-on configuration on different vendors. Thank you so much for watching this video, and again, just a kind reminder that if you haven't subscribed to our channel, kindly support us by hitting that subscribe button, and also remember to like, comment, and share this video with your connections. Thank you so much, and see you in the next session.